Okay, so the other day, we learned how to solve equations like this. X squared minus 2x minus 3 equals 0. And what we saw is it was not linear because it had a square. And so our method was get everything on one side, 0 on the other, and then factor it. Can you factor x squared minus 2x minus 3? It factors as x minus 3 and x plus 1. And then we take each piece equal to 0. And you're exactly right. We get x equals 3, x equals negative 1. What if I change this problem very, very slightly? And I change it to x squared minus 2x minus 4 equals 0. The problem is it doesn't factor, does it? Does that mean it doesn't have answers?
No, it still does.
It still does? In fact, if we wanted to, we could draw a graph of that. That's what I'm going to do. We could draw a graph, x squared minus 2x minus 4. Draw a graph. Oops, bad window. Zoom 6. We can see that it has answers. It equals 0 right there. It equals 0 right there again. So it looks like one of the answers is just a little bit bigger than 3. The other one's around a negative 1. So it has two answers. It's just the answers are not nice answers. What I mean by nice is they're not like 3 and negative 1. They're ugly little decimals, ugly little fractions perhaps. In this case, they're ugly little decimals actually. So what we're going to learn over the next couple days is how do we solve equations like this when they don't factor? And today we're going to look at two different methods. And we're going to look at the square root method, and then we're going to look at a different method called completing the square. So before the day is over, we will actually be able to solve this equation. We'll figure out how to do that. But before we do that, we've got to talk about the square root method. Alright, so here's a nice, simple looking equation. X squared equals 9. Take the square root of both of them and you get x equals 3 and you're half right. Alright, so we have an x squared in it. When we have an x squared, how many answers do we get? We get 2. And the way we did this the other day is we would move the 9 over and then we would factor. And we would get our two answers. X is 3, x is negative 3. So that's what we did the other day. Here's what we're going to do today. We're going to have x squared equals 9. How do I get rid of a square? What's the opposite of a square? Square root. So we're going to square root both sides. Now the deal is, when you square root both sides, there are two square roots. Positive and negative. So when you square root both sides, you need to remember to put a little plus and minus in there. There's a positive square root and there's a negative square root. So our answer, we would write it as x equals plus or minus 3. Which is exactly the same as what we had before. X equals plus or minus 3. Now, one warning. When you go to do your homework on MyLab, there's no plus minus symbol like this on MyLab. You actually have to write the two answers separately. You have to write a 3, comma, negative 3. That's the way it accepts it. On a quiz, on a test, or anything that you turn in directly to me, plus minus 3 is just fine. That's the way I'm usually going to write things. All right, well, that allows us to solve some equations that we couldn't solve before. For example, if I gave you x squared minus 10 equals 0, x squared minus 10, that doesn't factor because 10 is not a nice perfect square. But what we can do is move the 10 to the other side. X squared equals 10. And then what? Take the square root. And again, when we take the square root, we remember that there are two of them, a positive answer and a negative answer. So our answer would be x equals plus or minus the square root of 10. I don't care. My personal preference would be I would prefer you leave it just like that. If you want to type it into your calculator, get a decimal, that's fine. When you're doing your homework on my lab, follow directions. Sometimes it says give your answer as a decimal rounded to 2 places. In that case, you're going to give your answer as a decimal rounded to 2 places. Generally, I think my lab wants your answer written this way too. But again, on a quiz or a test, if you typed it into your calculator and gave it a decimal, that would be fine. All right, now sometimes it's a little bit more complicated than that. 15 maybe. Sometimes you don't have just the letter x squared. Sometimes you're going to have a thing in parentheses like that, squared, and then it equals a number like 15. What would you do? So you want to take this thing and you want to FOIL it out? Okay, we can do that. I'm going to tell you right now it's a very bad idea, but we can do that. And we'll see why it's a very bad idea. All right, so when I take x minus 2 times x minus 2 and I do FOIL, I'm just going to go quickly. You get x squared minus 4x plus 4 equals 15. Check it, make sure I did that right. X minus 2 times x minus 2. Move the 15 over. X squared minus 4x minus 9 equals 0. And we run into a big problem. It can't factor. It doesn't factor. Minus 11? Still doesn't factor. Still doesn't factor. Minus 11. Yeah, I got to quit listening to people. That's okay. Still doesn't factor. All right, in general, if you have something like this, doing FOIL is a very, very bad idea. You almost never, ever, ever want to do FOIL. FOIL is a 4-letter math word. Starts with F even. It's a bad thing. 4-letter math word that starts with F. Don't FOIL. Almost always a bad idea. We didn't do anything wrong there. We just didn't do anything helpful. All right, what you really want to do, if you have something squared like that, you want to get rid of the square. How do you get rid of the square? Do a square root. So as long as the thing's inside a parenthesis like that, I can square root the whole thing, and it wipes it out. The square and the square root are inverses, so I'm left with x minus 2 equals plus or minus the square root of 15. And then how do I get the x all by itself? Add 2. And so again, we're going to leave our answer this way. X equals 2 plus or minus square root of 15. And again, on a quiz or a test, you can leave your answer exactly like that. When you do your homework on my lab, you'll have to write x equals 2 plus the square root of 15. X equals 2 minus the square root of 15. And if you need decimals, then you need to type this one into your calculator, and then you need to type that one into your calculator and get the 2 decimals. Again, as far as I'm concerned, just like this is fine. All right. Now, sometimes it gets even worse. Sometimes you have a parenthesis like this, and you got something inside. What do you want to put inside? 7x. A 7 again? Yeah. Plus 7 squared. Minus, and then we've got some number over here.
7.
No, we're going to use a different number. 12 equals 8. I heard 8. All right, what do you do here? We're okay with all the 7s. We'll take care of those in a minute. Add the 8?
Yeah.
Close. Add the 12. Why do I want to add the 12? I want to get, what I really want is this thing with the square. I want it all alone. Why do I want that all alone? Because then I can square root it and make the square go away. All right, so if you have a parenthesis like this and a square here, that's fine. What you want to do first is get this thing all by itself. So I'm going to write this as 7x plus 7 squared equals 20. I want to get that thing all by itself first. if there was a number in front here that was multiplying, I would divide by that number too. I want this thing exactly all by itself. Why? Because then I can square root, and when I square root, it reduces with the square. Alright, so that gives us 7x plus 7 equals plus or minus the square root of 20. Subtract the 7. Alright, so typically we would write that as 7x equals minus 7 plus or minus the square root of 20. We tend to put the square root thing on the end and then divide by 7. So x equals negative 7 plus or minus square root of 20 all over 7. And again, on my lab, you would split it into two. If you needed decimals, you would have to type in the one with the plus and then the one with the minus and work it all out. We're going to leave our answer just like that. Questions on that? All right, so that leads us up to completing the square. What was that problem I had written down originally that I said we would get to today? Here we go. X squared minus 2x minus 4 equals 0. We saw, unfortunately, that this did not factor. Which formula? Oh, I don't know the quadratic formula. You should not believe everything I tell you. I think that's the next section.
Oh, is it?
I think so.
We're
We're not there yet.
I mean, if we use that, this whole thing would just be easy.
Well, from what you said, you don't know the quadratic formula correctly. I heard some things wrong.
I mean, if it comes down to like a complicated.
You could probably figure it out. All right. Well, for today, we're going to use a method called completing the square. And the reason we're going to use this method first, before we talk about the quadratic formula, which some of you know, is in order to prove that the quadratic formula really works, you use the method of completing the square. So the quadratic formula is really just a special case of completing the square. So here's the idea. What we would like to do is we would like to take this equation and transform it into something that looks like that. Where I'm going to have some stuff inside my parentheses and I'll have a number over here. Why would I want to transform my equation so that it has a parenthesis with a square and a number over here? Because then I can take the square root of both sides. And that's the whole idea behind completing the square, is we rewrite the equation in this form. And it's called completing the square because this is a square, something square. All right, so here's how that works. You're going to rewrite this as x squared minus 2x equals 4. Well, I didn't do a whole heck of a lot there. What did I do there? I moved 4 over to the other side. That's all I did. Nothing very special. Now we're going to rewrite this. We're going to write x squared minus 2x plus a special number equals 4 plus the special number. So we're going to add just the right number to both sides so that the left-hand side will factor with a square like this. All right, so here's how you figure out the magic number. You take this number in the middle. This number in the middle is a negative 2. You take the number negative 2. You divide it by 2. You're always going to divide it by 2, no matter what that middle number is. And then you square it. So what's negative 2 divided by 2? Negative 1. And then you take negative 1 and you square it, you get 1. So there's your magic number for this problem. Your magic number is 1. So I add 1 to both sides. What should happen now, if my magic number was correct, x squared minus 2x plus 1 should factor, and it should factor this way where the two pieces are exactly the same, so I can write it as a squared. It would be x minus 1 and x minus 1 again, wouldn't it be? So we write that as x minus 1 squared. And on the other side, 5. All right, so that's called completing the square. I rewrote this equation in this form where I have a perfect square because now I know how to solve it, because this is what we just did 2 minutes ago. Now we take the square root on both sides. X minus 1 is plus or minus the square root of 5. Add 1 to both sides, x equals 1, plus or minus square root of 5. Questions on that? All right, let's try another one then. X squared plus 6x minus, oh, too early, I wrote 5, equals 0. Alright, so to solve this by completing the square, we start by adding the 5. So a little different from what we did the other day. The other day we always said get 0 on one side, get everything on the other. Here we want the x's on one side and the 5 on the other. Alright, then we figure out the magic number. I take 6. I divide it by 2. And then I square it. I always take the middle number, which is 6, divide it by 2, and then square it. What's 6 divided by 2? 3 squared. 9. So I'm going to add 9 to both sides. X squared plus 6x plus 9 equals 5 plus 9. If I did it correctly, if my magic number was the right magic number, the left-hand side should factor in a very nice way. X plus 3 and x plus 3 again, isn't it? Because 3 times 3 gives me 9. 3 plus 3 gives me the 6. So this factors as x plus 3 squared equals 14. Square root both sides. X plus 3 is plus or minus square root of 14. Subtract 3. X equals negative 3 plus or minus square root of 14. Questions on that one? What'd you say? You want a hard one?
Yes.
Yes, all right. Something ridiculous. Well, I'm not even going to go ridiculous yet. I'm going to go hard and then I'll go ridiculous. How's that? X squared minus 7x. We're stuck on 7s today. Minus 72. I'll throw your 72 in there also.
Equals 9.
Equals 0.
Why not?
90.
Yeah, there we go.
There. Equals 90. What do we do?
You would
Add the 72 over there. All right. X squared minus 7x equals 162. That's not really where the problem is, that big number. Here's where it gets to be a pain in the neck. For my magic number, I have to take negative 7, divide it by 2, and square it. Now, negative 7 divided by 2 does happen to be negative 3.5. What's negative 3.5 squared? Something. Happens to be 12.25. You're better off leaving things in fractions here. And I know you don't like fractions, but you're better off leaving things in fractions. Because it's easier to square when it's a fraction. To square it when it's a fraction, you square the top and you square the bottom. So what's negative 7 squared? 49, and 2 squared is? 4. So our magic number is 49 over 4. Easier to leave it in fractions than it is decimals in this case. Leave it in fractions. All right, so we're going to have x squared minus 7x plus 49 over 4 equals 162 plus 49 over 4. Make sure you add it to both sides. That's a mistake I'll see. People remember to do it to the left, but they'll forget the right. Watch both sides there. Why do I drop the negative? Because when I square it, negative 7 times negative 7 is positive 49. Two negatives make a positive. So this will always be a plus here. You will always add. Always, always, always. It'll never be a minus. Always. Always. All right. If we did stuff right, the left-hand side should factor. Should. So I need two numbers that multiply to give me 49 over 4 and add to give me negative 7. Some number. All right. It's not as hard as it sounds. Look back up here. What was 6 divided by 2? 3. And notice that 3 was a number that showed up inside my parentheses. Over here, what was negative 2 divided by 2? Negative 1. And negative 1 was the thing that showed up in my parentheses. What's negative 7 divided by 2? It's negative 7 over 2. What goes inside my parentheses? Negative 7 over 2. So it's not as hard as it sounded like it was going to be. All right, so the thing that goes into parentheses here is always the number that you had right before you did the squaring. It's always that number that's inside those parentheses right there, always. Say that again. What's going to be 4? Nope, the number I put in the parentheses is negative 7 over 2. So I have x minus 7 over 2 squared. On the right-hand side, of course, I have to add those fractions. That doesn't scare me because I have a calculator that doesn't. 162 plus 49 over 4. Well, then I'd have to do it by hand. I'd have to get a common denominator and do it. But, 697 over 4. Okay, now what? I can't add the 7 over 2 yet because it's still trapped inside this parenthesis with the square. I got to root it. I got to take it out of that parentheses first. I got to square root both sides. X minus 7 halves equals plus or minus the square root of 697 over 4. Now, looking at this thing on the right-hand side, the square root of 697 is not a nice number, but the square root of 4 is a nice number. So typically we would do that if we can. The square root of 697 is square root of 697, some ugly decimal, I don't know what it is, but on bottom the square root of 4 is 2. So typically we would write it that way. And why is that helpful? When I add the 7 halves over, they have a common denominator now, don't they? So we would add the 7 halves, and you could write it like this: x equals 7 halves plus or minus the square root of 697 over 2. But quite often this would be written as 7 plus or minus the square root of 697 all over 2. Since they have a common denominator, we add the tops and we leave the bottom alone. Questions on that? All right, now you're ready for the really hard ones.
Yeah.
Yeah, good.
Not going to take us 5 pages.
It won't take us 5 pages. You might notice on all these problems that I did with completing the square, there was always a number 1 right there. There wasn't any number, which means there's a number 1. So we had a 1 right there. We had a 1 right there. We had a 1 right there. We had a 1. They all had the number 1.
Let's just get crazy.
Let's get crazy and not put the number 1 there.
So the number 92.
Well, let's not go too big first. Let's start relatively small. I think we've used 7 to death today.
7.56.
6x squared
6x
minus
minus 6x.
6x. I'm going to go minus 5x.
No, we need minus 6x.
No, we wanted it hard. We're going with a 5. I'll put a 6 over here for you, though. Minus 6. D6 equals 0. 6d6. Changed it to no. All right, so here's the deal. In order to complete the square, you cannot have a number here. It's got to be just a 1. Nope, not grouping. It's even worse. I can't factor a 6 out. 6 is not a common factor. What I'm going to have to do, unfortunately, is get rid of that 6. The only way to get rid of that 6 is to divide everything by 6, which can give me fractions right from the very beginning. So this is where these get ugly. When that first number is not the number 1, you have to divide through and you get ugly fractions right away. So we have x squared minus 5/6x minus 11 equals 0. Add the 11. That's not so bad. X squared minus 5/6x equals 11. Oh joy. Correct. I need to take my number in the middle, which is negative 5 over 6. I need to divide that by 2. And then I need to square it. All right. So how do I take negative 5 over 6 and divide it by a regular old number like 2? It would be 5 over 12. Why is it 5 over 12? That sounds it's correct. Sounds more complicated than what I was thinking. I was thinking I'm going to take 2 and write it as 2 over 1. And then how do I divide 2 fractions? You flip the bottom one. So this becomes negative 5/6 times 1/2 squared, which is negative 5 over 12 squared. So my magic number was negative 5 squared. 25 over 12 squared. 144. All right, so this is as hard as these can get right here, really. When you start with this first number is not the number 1, you have to divide, which gives you a fraction here, and then you're going to mess with the fractions to find your magic number. This is really as bad as these can get. Maybe, I don't know. No, there won't be another variable. Well, there might be the letter Q everywhere instead of the letter X, but there will never be 2 variables. That won't happen. All right, so if we did this right, this factors as it has an X. What else goes inside the parentheses? Minus. What? I'm just looking for. It's negative 5/12. It's x minus 5/12. It's always a number right there, right before you squared it. So it's going to be x minus 5/12. And then over here again, I'm going to grab my calculator. Add those fractions. 1609 over 144. Oh. It's a what? It's a pretty number, okay. Pretty number, I suppose. All right, I'm going to square root both sides. X minus 5/12 equals plus or minus the square root of 1609 over 144. That's plus or minus the square root of 1609. The square root of 144 happens to be a nice number. 12. And again, you might see a pattern here that works out so that we have common denominators. Should always work that way. All right, final answer. X equals 5/12 plus or minus the square root of 1609 over 12, or more commonly, we would write it as 5 plus or minus the square root of 1609 over 12. Questions on that? What's that?
That's what
Well,
I'm saying. It's a lot easier than just doing all this.
Are you the purpose of trying to learn the mechanics of the clock? Is that
Now
what
he has to
you're
teach this stuff.
I would argue that with practice with completing the square, it's quicker to do this one by completing the square than it is using the quadratic formula. When the problems are easy, completing the square is faster. And what makes the problems easy? They're easy when this number is a number 1 and this number is even. Why is it important for this number to be even? Because eventually I have to divide it by 2. So when this number is a number 1 and this number is even, with a little practice, completing the square is actually quite a bit faster, I think. And like I say, the truth is, the quadratic formula is derived by completing the square, and we will actually go through that on Friday. And there are other things that you use completing the square for that don't involve solving quadratic equations. And so the technique of completing the square is useful. For example, I told you we wouldn't have 2 variables, but you might.
You might as well just go all the way. I mean, you just have 2 separate.
What you will learn at some point, I think we cover it later in this class, I'll have to look. That equation that I just wrote there, that equation gives you a circle. Believe it or not. If you have an x squared and a y squared like that, that equation gives you a circle. In order to deal with this circle, we would complete the square here and we would complete the square there, and we would actually write it in this form. How I do all this right now, you don't really need to worry about. We would write it that way. And the reason we would write it that way is that these 2 numbers tell us the center of the circle. So this circle is centered at 1, 2. And this number over here is the radius squared. The radius is the square root of 5. So, in order to do that, in order to take this equation and rewrite it in that form, you have to know the technique of completing the square. So completing the square is used for more things than just solving quadratic equations. And that's one of the other reasons why we teach it to you now. It's a method for solving quadratic equations. It's usually not the best method. In fact, it's usually the worst method. So what's the best method? Depends on the problem. True. But if I gave you this question, x squared minus 2x minus 3 equals 0, I think I already gave you this question earlier in the day. The quadratic formula is not the best way to solve that problem. The best way to solve it is not the square root method. Guessing wouldn't be a bad way to solve that one, actually. The best way to solve that one is to factor. If this first number is the number 1, factoring's pretty easy. This one factors as x minus 3, x plus 1 equals 0. When you can factor, factoring is usually the best way because it's usually the fastest and most efficient way. Can you solve that one using the quadratic formula? Absolutely you can. Can you solve that one by completing the square? Absolutely you can. You don't want to. It takes longer. So that's something, and that's something that makes quadratic equations very difficult, is you need to look at the equation and first decide which method is a good way. Every quadratic equation can be solved using the quadratic formula. Every quadratic equation can be solved by completing the square. So you can always use those two ways. They're just not always very efficient. And we'll see the quadratic formula. We'll see it Friday. I'm pretty sure that's the next section. We'll see it and we'll use it. And we'll try it with a problem like this, and we'll see it takes us twice as long to do this one using the quadratic formula as it does to just factor it. Yeah. And again, the issue is, if I change it to this, that one doesn't factor, so I can't solve it by factoring. Now I have to use a different way. So now, do I want to complete the square, or do I want to use the quadratic formula? Most people, most of the time, say, I'm always going to use the formula. And that's fine. That's fine. I think if I were doing this one, I would do it by completing the square, because this is a 1 and this number's even and it goes quickly. But that's me, and I've done completing the square thousands and thousands of times in my life. You've seen it demonstrated 3 or 4 times today, so to you it doesn't make a lot of sense. It doesn't seem real quick and real easy. To me, based on experience, completing the square is very fast, and I do it quite often when I have to. Correct. Sometimes you need the quick answer. Yeah. Well, all right then. I think that's enough for today.